For this first question, we've got fractions. Now, this one's not too bad. If you lay it out like this, and then simply multiply the numerator, and you get 2, and the denominator, you get 21. So the answer there would be 2/21. This one, however, is a little bit more tricky. What you need to be looking at when you've got a question like this is trying to get the denominators to match. So one nice easy way of doing that is to look at the lowest common multiple of 3 and 5, i.e. the lowest number you can find that 3 and 5 will go into. If in doubt, you can just find it by multiplying these two numbers together, but it won't necessarily be the lowest. So for this fraction, I'm going to times the top and bottom by 5. And in so doing, I'm really just timesing it by 1, because 5 divided by 5 is 1. And on the left fraction, I'm timesing top and bottom by 3, which again is the same as timesing by 1, so I'm not really changing the value. Then, here's the nice part. Once you've looked at that, you can then just multiply like you did in part A, and you'd get 9/15 minus 5/15. And now the denominators match, so you're left with 4/15, and that will be the answer you'd put just here. So what I'll do is I'll just do another example here. Say you had 2/3 times 4/7, then you just have 8/21. Another one like this, if you had 7/9, take away 1/6, well, you could times top and bottom here by 9, and top and bottom here by 6. That's the quickest way of doing it, and you'll be left with 42/54 minus 9/54, which would be 33/54. But that can be cancelled. It doesn't say that in the question like this, but if it does, you'd lose marks. So in this case, this is 3 times 11, and this is 3 times 18. So the answer in this case would be 11/18. So coming back to here, if you had 7/9 and 1/6, if you wanted to find the lowest common multiple, then think carefully, because the 9 here is made up of 3 times 3, and the 6 here is made up of 2 times 3. Now it's clear to see that they have 3 in common. So does that help you find the lowest common multiple of 9 and 6? Have a think about it. Well, hopefully you've worked out it's 18. And one way of looking at it is if you times this one here, top and bottom, by 2, and this top and bottom by 3, then you'd have a 2 times a 3 times a 3 here, which is the same as the 2 times the 3 times the 3 here. Now, what you'd be left with is 14/18 minus 3/18, and that gives you 11/18, which is what you had here. One further way of doing it is if you do the 9 times table and the 6 times table, and you look at where they're the same, the quickest number where both times tables seem to coincide. So there's a little bit on the fractions there. Let's move on to the next question. Well, with this question you've got to be careful because it wants an ordered stem and leaf diagram. First of all, get the key done, because apparently you're supposed to be able to understand these really clearly, so you need a key. So let's get that out of the way for starters. So I'll go with this number and say that 13 is the same as 1, 3 on my stem and leaf diagram. and having not seen this paper before, it's probably waiting for me underneath here. Yeah, there it is. So we'll just put it in here. 1, 3 is the same as 13. Right, so let's get back to the actual question here. It wants it all ordered. So what we can do is we can start to put the numbers in here that they start with, the roots of the numbers. That's like the stem of the number. And then before you start putting the leaves in, what I suggest you do is do a little one at the top here on the side and put all the ones that start with 0 and just cross them through as you do them. So you've got a 5 here and then a 9, and there are no more that I can see. And then you put the one starting with a 1. So let's have a look at those, and I'll say 9. There's an 8 there, a 15, a 16, and a 19. I'll come to order those later, so I'm not going to worry about that just now. So the one starting with 2, so that's 1 as a leaf, 7 as a leaf, 3, 9, 5, 8, 3, and 2. And then the ones with a 3 starting as a stem, there's a 1, and there's a 2 here, and a 4, and the one with the 4s, then there's a 0, and then let's not forget this little one here, which is circled in green. That nearly got away there, so there we go. Let's kill that one off. There we have them. So all we've now got to do is actually order these leaves, okay? So don't forget, this is a stem, and these bits are the leaves, okay? So for the first one, we're going to have 5, then 9, and then we're going to have 3, 5, 6, 8, 9, 9, and then 1, 2, 3, 3, 5, 7, 8, 9, and then 1, 2, 4, and then 0. The nice things you can do with stem and leaf diagrams are you can do them back to back, so you could have things coming off this side as well for a different set of data if you want to compare them. You can also look at them as a bar chart if you turn the page. You can also find the median of a set of data and other things, but that's not in this question, so I'm not going to go off on a tangent too much. I'm going to stick to what the question says. So that's how you do an ordered stem and leaf diagram. Let's have a look at this one. Now, in this question, I suggest you kind of underline some of the bits that are important. So you've definitely got 50 people. It tells you about they either go swimming, squash, gym, and then it starts to list some of the information here. And what you have to do is work out the number of females who used the gym. So that's the really important part. So it's really testing on whether you can look at a question, take the information, and do it efficiently. So I think for this question, what seems to be a good idea is to do a quick table. So we'll just have males, females down the side. Hasn't got to be anything special. And then you can put swimming, squash, gym, and then you can have the totals down here. Now let's just go through this information. It says 21 of the people were female, so by default that's going to mean you're going to have 29 males. Then 6 of the 8 people who played squash were male, so 6 were male, that means 2 had to be female. And then it said 18 people used the gym altogether and 9 males went swimming. So if 9 males went swimming here, that must mean that this column down here already has to add up to 29, and we've already got 9 in the 6, which gives 15, so there's got to be 14 left. So can you work out now how many females went to the gym? Well, the key is here. 18 people used the gym, so it must have been 4 females. I find these questions a little dull, to be honest, but if you just lay your workings out, let's have a look at how many marks this question is. It is 4 marks, so I think the fact that you've shown a table of results is a good idea, because even if you get the answer wrong, you'll pick up something, okay? So for this one, you just have to work out the total cost here of the tickets when Mr. Brown uses his family rail card. So you need to think, what was his family consisted of? Well, himself and his 2 kids. Okay, so first of all, he's going to go, so his adult ticket is £24, and he gets 1/3 off. So how many 3's going to 24? That's 8. So he gets £8 off that. So he pays 16. So that's that one done. And you can write Mr. B here. Now, for his children, they're £12 each. So child 1, child 2, both going to be the same. So they're £12, and you've got to find 60% of 12 and then take it off. Okay? So I think some literacy here, you can get confused between of and off. So if we do 60% of 12, well, 10% is 1.2, so 60% will be 6 times greater, which will be 7.2, but in this case it will be £7.20. So that's how much you get off for each child. So you take the £12 and then you subtract £7.20. You can either count up. If you counted from 7 to 12, you'd get 5, so you're going to be on £4.80, aren't you? Okay, so that's how much each of the kids cost, and then you just got to work out the total, really, so you can just add that up. So you get £16 and then 2 lots of £4.80. So what you're going to get, 0 here, 16, and then 10, 14, 15. So the answer will be £25.60. Well, these are probably my least favourite questions on the entire GCSE syllabus. Questionnaires, I love them to bits. I think the main thing with the questionnaire is you've got to ask a question which is not leading someone to a certain answer, and you've got to ask a question that your answers can be pigeonholed or classified into particular parts that don't have any overlaps. So for this one, I think I would say is how many books do you buy a month? And then just give some choices here. So we'll put some boxes here. What should we say? None. Maybe 1 to 2. Don't say 2 to 3 because that's got an overlap here. So you can say 3 to 4, 5 to 6, and then maybe just 7 or more. Okay, so keep it nice and simple. Don't make it too difficult for yourself. Imagine that you're being asked the question yourself. So let's have a look at this next one here. It says, expand 2m brackets m plus 3. So what I would do here is I'd do a grid. And then just multiply through. So you'd have 2m squared, and then you'd have 6m. So when you come to write your answer, you can either write 6m plus 2m squared, or 2m squared plus 6m. Now, these kind of questions, they can catch people out quite a bit. So let's spend a little bit more time on this type. My advice is I would write everything out like so. And of course, there's implied multiplication here. And then try and look at what they have in common. So you've got two expressions here. You've got 3x y squared, or 3 times x times y, and here you've got 6 times x times y. So try and think what they have in common. So you can see, yes, x is something they have in common, so you can try and put that to one side. And then they have y in common as well. So they have xy in common, x multiplied by y. But the thing that students sometimes miss is this. So when you've got 3 times x times y, try and break the 6 down into its prime factors. So prime factor decomposition is really important, because if you break that down into 2 times 3 times x times y, then it's soon apparent that they also have 3 in common. So that's what would be outside of the bracket. And then inside the bracket, what would you have left? So let's not confuse things. Let's cross this one out here. Let's make sure we've circled what they have in common. Notice it doesn't matter which y I circle here. So we've got 3xy and 3xy, so that's good. And then what is left? Well, in this bracket we have y left here, minus, and then here we've got 2. And I strongly suggest that you check your answers by just multiplying out. That's if you've got time, okay? You may not have time in the exam. So multiply these out and you'd get 3xy squared, yes, minus 6xy, yes. So that would be the answer just here. So watch out for those types of questions. They can be quite tricky. Now, for this question, you can see that it's already been highlighted here. I didn't want to forget how to speak about these QWC questions, quality of written communication. What it means is you can do the question how you want, but the way that you do it has really got to make sense and got to be clearly laid out and be reasonably efficient. Okay, so there's no law saying how you have to do this question, but just please lay it out really clearly. Okay, it's something that the government changed a number of years ago to try and get students and teachers to try and get work laid out really well and for things to make good mathematical sense. So I think in this question, okay, we're talking about pigs here. It could have been anything. And it says that each pig needs an area of 36 square meters. So really the first thing to do is to try and find the area. So how would you do it? Well, I'm going to do it this way. So I'm going to box this one off here. And that's going to be 7 by, well, this is 10 here. And I'm going to take 6 off. So that'll be 4 meters. So this one here will be 28 meter squares. And then what's left will be 6 times 16. Now, this is important. So if you do 6 times 16, then show your workings. So here you can say 96. I'm going to write in this margin here, but I don't suggest you do in the exam. So you've got 6 times 16, that's 96 meter squares. And then you can have the total area. Again, I'm looking at this QWC, so I want to show everything. So 96 and 28. So we've got 124 meter squares. But it says each pig needs an area of 36 metre squares. So my advice would be to say one pig would be 36 metre squares. So 2 would be double this, which would be 72. And then I'll just scroll up a little bit. And so then you'd have 3 would need, well, you can either add that or do the 36 times table. I'm sure you won't have to show your workings for that if you just said 108 metre squares. And then 4 would be, well, you can do 108 add 36, which is 144 metre squares. So you need 144 metre squares for 4 pigs, but you only have 124 metre squares. So you can have 1 pig, you can have 2, you can have 3, but you cannot have 4. So I would just say 3 pigs. Now, I'm sure I'll get comments from people saying I've not set my work out very well. I don't really care, but that's how I would do it. So if I lose a mark, then please tell me I've lost a mark. But that's as best as I can lay it out in the space that I've got. So let's move on to the next question here. Well, the diagram shows a garden in the shape of a rectangle. The scale of the diagram is 1 centimetre, represents 2 metres. Now, the way I'm doing this is I don't have a compass at hand, and I don't have a ruler at hand either, but what I can say to you is this is all about following particular rules. So this is all about locus, and the word locus just means a path of points, and its plural is loci or loci, as some people say. Now, for this, the scale is the thing you need to watch out for, so we'll definitely have a little look at that. It says 1 centimetre represents 2 metres. So let's have a look at what the rules are here. So Irfan is going to plant a tree in the garden. The tree must, so it's must be more than 3 metres from the patio. So I take it this lovely grey shaded area here is the patio, and you've got to be 3 metres from it. So you want to be 3 metres from it, but obviously you're not going to have a rule of 3 metres long in the exam, so you've got to look at what 3 metres is in centimetres. Well, you know that 2 metres is 1 centimetre, so 1 metre is going to be half a centimetre. So if you add these up, you'll get 3 metres is going to be 1.5 centimetres. So if you just measure with your ruler 1.5 centimetres to here, and then obviously I'm going to do this roughly here. And there you go. That's the first rule. That's done. More than 6 metres from the centre of the pond. Well, 6 metres is going to be 3 centimetres. So here's the pond here. Now, what you'd have to do in this situation, now with this question here, you've got to go 6 metres from the centre of the pond, okay? So you really just get your compass, you put your sharp point here, and then your pencil, hopefully, 3 centimetres, and then you would basically try and draw a circle all the way round, okay, which I'm not going to do very well, but I'm giving it a try. Okay, so there's your circle. Now, you must try and now think what the question is asking. It's saying more than 3 metres from the patio, so 1.5 centimetres, and I will add, you just make sure that that is 1.5 centimetres well, okay, because this line down here, this red line, has got to be perfectly at right angles here. So that's the first thing. And the second thing is, it says it wants more than 3 metres from the patio, so it's definitely going to be coming out this way. But can you see where the circle is telling you what the answer is, because you want to be more than 6 meters from the center of the pond as well. So if you think about it, you can have all of this area here, but you can't actually be on the circle. If it wanted more than 6 meters or the same as 6 meters from the center of the pond, then you could actually be on the outside of the circle, which I'll show here. You could be on here, but it wants more than, so you do a dotted line, and then it also wants more than from the patio, hence a dotted line down here as well. So the only area you can actually be is the green shaded area, but you can't be on the circle and you can't be on that red line. Okay, so you've got to be careful of that. And that's what I would go for as the answer. So on this question, question 9, it's probably going to ask you to translate or rotate or reflect, do something to the trapezium that we see here. Okay, so that's the first thing to think about. So let's have a look at what it's asking. It says, on the grid, rotate the shape A 180 degrees about the point 1, 1. So let's get the point 1, 1 on here for starters. Now, one good way of doing this is you can actually draw straight lines from each of the vertices of the shape and have them go through that center 1, 1. Okay, so that's the first thing that we're going to try and do without a ruler, so it could be difficult. So if you try and look carefully here, for example, if you went along up 2 and along 1, think about doing the opposite, down 2 and along 1 this way. You should get to the same point. And don't forget, both of those points are on this line. That's really important. So there's our first point here. And then we can do the same thing again. I'll do it in a different colour. You can say 1, 2, 3 along and 2 up. So you can actually go 1, 2, 3 along and 2 down. And these should be nice corresponding points. And check they're on the same straight line, which they are. So there's your second point. And then you can carry on doing that. So if we go from the centre again, we'll go 1, 2, 3, 4, 2. So we can go 1, 2, 3, 4, 1, 2. Okay, so these will all be corresponding. Check they're on the same straight line each time. And let's have a look at the last one here. Well, let's choose a different colour. So let's go 1, 2, 3, and then 1, 2, 3, 4. So 1, 2, 3, 1, 2, 3, 4. So you can see all the vertices here. So I'll do them in another colour here so you can see them all. There's 1, 2, 3, 4. And all you have to do is join those points up. And that should be your rotated shape. Now, I certainly would ask for tracing paper in the exam, because one thing you can do is just put a centre in here, 1, 1, and then just basically with the tracing paper go over this shape here. You can then put your pencil at this point here, and then with your finger you can just move the whole diagram around. So I don't know whether I can do that on here. No, I'm not even going to try. So you could just move that around. I'll have one last try at showing. I think you can do this. There we go. And then you can, hold on a second, and then we can try and do it the other way. If I can, there we go. So you can see just how this is beginning to work. So that's as best I can do it on here. There we go. It's really tough to do this. So there you go. I'm going to do one more. So let's do it. It's 180 degrees. It will go clockwise, and there we go. We should end up to where we ended up with, just there. Okay, so that's quite tough. But I hope you've understood what's going on. Right, let's get out of that one. Let's have a look. Right, next question. So, with this question, it wants you to do something again to this little triangle B. It says, on the grid, enlarge the triangle B by scale factor 3, centre 0, 0. Well, there's our centre here. Now, I don't mind doing these questions really, because it's the same as before. You try and draw some rays, like the sun's rays, going from the origin to the vertices marked here. So I'll set those up first. Right, so they're done. And then we want to look at the keywords here. So we want to enlarge it. Now, an enlargement doesn't have to mean making it larger. It can mean make it smaller as well. By a scale factor 3. So we're looking for corresponding points here. So we've got this one was 2. We're looking for a 6 going from this line to this line. So is that going to be 6? No, it's not. What about this one? 1, 2, 3, 4, 5. There we go, we've hit on it. Of course, you'd use a ruler. And then if this one's 1, there we go. This one will be 3. And then we just join the other two up. So let's have a look. There we go. So that's quite a nice method. Just make sure that, like in the previous one, when you've got your rays, your corresponding points are on the same line, then you can't really go wrong. So that would be my answer to that one. Let's have a look at the next question. So this question, we've got QWC again, quality of written communication. So you really want to make sure your working is set out really well. And like I said, you'll have your own ways of doing this. So I'm just going to try and show you how I would actually do it if I was in the exam. So it says a 4-pint bottle costs £1.18 and a 6-pint bottle costs £1.74. Which bottle of milk is best value for money? Right, so I think that's what it's trying to say is, if you know that the 4 pints is going to be £1.18, then 2 pints would be half of £1.18, which would be, well, half of £1 is 50 and half of 18 is 9, so 59p. And then I would probably leave it at that. So I would probably say 2 pints is 59p for this one. So I'm going to set my workings out a little better than that. I'm going to say 2 pints would be 59 pence. Now I'm going to look at this one here. Okay, so I would say that the 6 pints was £1.74. And then 3 pints would be half of that. Well, half of 74 is 37, and half of £1 is 50. So 50 and 37, that would be 87p. But we've got to try and make these match here. So how would you do that? So I would know that 3 pints there is 87p, but 2 pints here is 59p. So I could go one more step and say both get them to be 1 pint, or I could say go from here instead and divide that one by 3 to get what 2 pints is. So what do you prefer? I think looking at it now, I'll go with 1 pint for each bottle. I'd say so half of 59, well, that is 29. 2 29s are 58, so that's going to be 29.5p per pint. And in this one here, don't forget I've got 3 pints here, and I want to get to what 1 pint is for this particular milk, 6-pint bottle. So 1 pint is going to be, well, I've got to do 3s into 87, so I'll do that here. So that'll be 2, 3 to 6 with 2 left over, so that's going to be 29p. So I think this question is not a bad one because it's pretty close. 1 pint in this particular instance is going to be 29p per pint, whereas in the first instance it's going to be slightly more expensive. Now, I think logic does tell you that if you went for a 6-pint bottle you'd probably get better value for money, but really just go by the numbers here, because you never know, next time it might not work out that way. So try and show while you're working. You probably could lay your work out better than mine, I have to say, but I'm quite restricted on here. I know that's an excuse, but you give it a try anyway and see what you think. But as long as you clearly say that at the end the 6-pint offer is best value. Okay, and I think you've shown the two scenarios clearly enough, so I think the examiner would know exactly what you're doing. Okay. Just reflecting on the question, I think one thing you could have done, different from this, because it's just one way, is you could have said in the first scenario here, so scenario 1 and scenario 2, so in the 4-pint scenario versus the 6-pint one, you could have got them both equal to 12 pints perhaps. So for this one you could have said 6 pints is £1.74, so 12 pints is £3, I think that's 48. Put your pound sign there. And then for your first scenario where you've got the 4 pints, the 4 pints is £1.18. So 8 pints would be £2.36, and 12 pints would be those added together. So 18 and 36, that's 54, and 2 and 1 is 3. So here you've got £3.54 versus £3.48, which kind of tells you really that if you wanted 12 pints, then this would still be the better situation. So there's going to be plenty of ways of doing this, okay, but there's 2 ways for you. So for this question, you've got a regular pentagon, so 5 sides here, pentagon, I think Greek is penta, so that's 5, and then regular, well, they're all going to be the same length. So work out the size of angle CFD. So first of all, just to know that you can write that this way as well, or you can write it as angle F in this instance, or angle CFD. Okay, so know which one you want. So CFD is going to be, this is the aim here, we want this one, this angle here. Okay, so first things first, I know that this would be the centre of my pentagon, and I'm just going to draw out some arms here. You don't have to do all of them. But the first thing to notice is that you would have a whole turn here, but split between 5. So if you do 360 between 5, well, that is 720 between 10, which is 72 degrees at the centre. So you'd know that one of those is 72 degrees here. Then if you looked at a triangle, one of these triangles here, then these angles would be the same because it's an isosceles triangle, because they're two, because the centre here, if we call this O to C and O to D here would be the same length. Now we know that angles in a triangle sum to, that's the summation sign, you probably won't know that, so I'll get rid of that. I'd say equal 180 degrees, so you've got 72 degrees already, so the 2 dots, what must they be? They must be 108, so one of them is going to be 54. So we can write in those as 54 and 54 degrees. Now I think looking at this question now, it's beginning to fall into place for me, because I think what nails this question is that angles on a straight line are 180 And if this is 54, this is 54 because all those triangles are the same. So this is 54 and that is 54. So angles on a angles on a straight line make 180. So we've got 108 there already just with these two. So 72 must be left. Now there is a nice little rule which basically works out the relationship between this angle here and this one in here, but I'm not going to go into that right now. So you could have done it that way, but I think just working around the shape is a more natural thing to do. Then we also know here, let's have a look at the question. Has it got any more information? It says BCF and EDF are straight lines. Now, if we think about this question here, as this was a regular pentagon, this will be the same as this, and this will be the same as that. So if we think about this being 72, then this angle here should be 72 as well, because this angle here was 54, and we can do the angles on a straight line again. So really, to find this angle here, well, we know that angles in a triangle, again, add up to 180. So angle CFD must be 180 minus 72 minus 72 more from the diagram from here. So if you think about it, 72 and 72, that makes 144 degrees. So the angle is going to be 36 degrees. So again, my working could probably be a little better, but what I'm trying to do is explain as I go around the shape. So that's how I would do that particular question. So in this question here, again, we've got QWC, so quality of written communication, and we've got some information. We've got a formula connecting C and F, which we can use, and we're probably going to be given some information here, and it says the minimum temperature should be 20 degrees centigrade, and Mrs. Smith is an elderly person, and the temperature in her home is 77 degrees Fahrenheit. So you've got to decide something. So I suggest before you do anything, you look at this formula quite clearly and you try and think, well, it's telling us that F is 77. So we're going to have 5 lots of 77 minus 32 all over 9. So let's work that through. So we'd have 5 lots of, well, 77 minus 32, so that's going to be 5, so that's going to be 45. And then the 9 here, and then look, 9s into 45, or 45 ninths is 5 whole ones. And so we're going to get 25 degrees centigrade. So that's what would happen if you put 77 into the formula. But what does it say? It says, decide whether or not the temperature in Mrs. Smith's home is lower than the minimum temperature should be. Well, the minimum temperature in the elderly person's home should not be any less than 20, it says here. And this is 25. So we've got to decide whether or not the temperature in the home is lower. Well, it is not lower. So Mrs. Smith's going to be okay. So let's see if there's any more. Right. This is definitely something I like doing. Now, you want to make F the subject of the formula. What it means is you want to rearrange it so F equals something. Okay, so you want to isolate the term with F. So let's have a look at what we've got here. Now, the first thing I would do is trying to get rid of this 9. Now it's being divided by, so if you multiplied both sides by 9, you would have 9c equals 5 lots of f minus 32. Then it would be absolutely fine to multiply out the brackets. Don't start thinking about adding 32 because that's not 32. It's connected with the multiplication of the number 5. So multiplying out the brackets is good. So we'd have 9c is 5f minus 160. If you're not sure how to do 32 times 5, then just do a multiplication problem at the side. Don't try and do everything in your head if you're going to make a mistake. Then I would add 160 to both sides, and that would give me 9c plus 160 equals 5f. And then I'm almost there, but 5 and the f are multiplying each other, so I'm going to divide both sides by 5 now, and I'll be left with 9c plus 160 all over 5 equals f. And that is personally what I would stick with. Now there's many ways of approaching this question, but I think that's probably the easiest. I'll just show you another way next to it here. I'll go from this stage here. So if you were at 9c equals 5 lots of f minus 32, you could divide both sides by 5 and have 9c over 5 equals f minus 32, and then you could just add 32 to both sides and you'd have 9c over 5 plus 32 equals f. This to me would be a lesser way of doing it. It's perfectly okay, it's really fine, but whenever I see a fraction added to a number, I try and get the denominators the same, so I would have probably times this top and bottom by 5, and I'd end up with what I've got here. But don't be worried, you just want to make sure you get the marks to start with, and just try and rearrange it to get f as the subject. As long as you follow the rules and laws of algebra, however you get there is absolutely fine. So don't stress too much on having to do it a certain way. There are many ways of doing it. So looking at this question yet again, we see that we've got, to show our workings really clearly, QWC, quality of written communication. I can't underestimate this enough actually, because having marked a lot of papers before, a lot of marks are lost because students are not showing their method marks. So it says a prize is won every 2014 seconds. Work out an estimate. So this is an estimate now, which is going to indicate there's a multitude of ways of doing this question. You've just got to show something which is close but efficient. So we've got 24 hours to work with. I think I would say to myself that 1 hour is 60 minutes, and 1 minute is 60 seconds. So 1 hour is going to be 60 minutes, which is 60 lots of 60 seconds. So do you see that? So 1 minute is 60 seconds, so 2 minutes would be 2 times 60, 3 minutes would be 3 times 60, and so on, all the way up to 60 minutes would be 60 times 60. Well, 6 sixes are 36, but we had 60 times 60, so it's 10 times more and 10 times more again, which is not 20 more, by the way. That's 10 times times 2. This is 10 times times 10 times. That's 100 times more. So we've got to the situation where we've worked out how many seconds there are in 1 hour, but it wants the number of prizes won in 24 hours. So 24 hours is going to be 3,600 times 24. Now it says a prize is won every 2014 seconds. So as this number here is now in seconds, because I've got 3,600 seconds and I've got 24 hours worth, so that's how many seconds, I'm going to have to divide that number by 2014 and try and work out an estimate. So an estimate is something that you should be able to work out reasonably well without a calculator, usually in your head. Doesn't always mean that, because some people are very weak at number and it's not particularly fair to expect them to do it, but give it a good try. So I would say here, do you know, I'd probably stick with 3,600 here for this number. This number here, I would say 25, that would be safe. And this number here, I'd probably say 2,000. So let's see if anything cancels. Well, we can divide top and bottom by 10, and then top and bottom by 10 again. And then let's just write that out. So I'd have 36 times 25 over 20. Then I'd probably halve this number here and halve this number here. And that would give me 18 times 25 over 10. And then I'd probably divide this number by 5 and this number by 5. So I'm left with 18 times 5 over 2. So using that cancellation, then you can see that you're going to get 90 over 2, which is 45. So I'll go with 45 prizes, but some of you are probably thinking there's no way that I would be able to do that. So I'm just going to try and do another estimate here. Let's have a look. So let's go from where we started. So sorry for writing off the edges here, but we've got 3,600 times 24 over 2014. Let's go with something else. I'm just trying to think now. I think you could probably say take the 3,600 to the nearest thousand, which you could probably work out is 4,000. That's to one significant figure in this instance, by the way, 1 SF. I don't want to get too much into that, but I just want to put that in while I can. And then look at this number to one significant figure as well, which is to the nearest 10 in this case, because this is the tens column, and that would be 20. And then try this one to one significant figure, so that would be to the nearest 1,000, because that's the thousands column here, and that would be 2,000. That's probably easier for most of you, although the first way would be okay as well. I would say then you can divide top and bottom by 10, top and bottom by 10 again, and once more, write out the next stage. So you've got 40 times 2 over 2, and you know the 2's will cancel as well because 2 divided by 2 is 1. So you've got 40 using this method. Okay, so I think either or would be fine, but you've basically got to do things that you can do without a calculator. That's the whole idea of estimation. The better you are at number, and some of you will be, the more you'll want to make it more accurate, and you're kind of losing the point then. You want to just make it rough and ready, so as an estimate. So I would probably, on balance, probably go with that one over this one, to be honest with you. Okay, but let's have a look at the next question. Well, with this question, unfortunately, you're going to have to know something about miles and kilometres. Now, if you know that 1 kilometre is 1,000 metres, well then that's good. One way of looking at this is if you see a track here, then if that's an Olympic track, that would be 400 metres from one place all the way to the start again. That would be 400. And if you ran that 4 times, that would be 1600 meters, which is roughly 1 mile. So I kind of remember running around a track 4 times in my head. And so 1,600 meters, I think it's 1,610 or something. Even I don't know exactly what it is. I probably should, but I'm sure someone will tell me later on. So I'd say roughly 1,600 meters is a mile, and that would mean that 1 mile is roughly 1.6 kilometers. So that's definitely something to keep in mind for this question. So if she wants to go to Dijon, then I would say that's 480 kilometers. Now, if we think about this, if we know that 1.6 kilometers is 1 mile, and that means 16 kilometers is 10 miles, and 160 kilometers is 100 miles. And then the nice thing about 16 is in the 16 times table you can get to 48 if you multiply it by 3. And if you can't see that, then you can just add another 160 kilometers, which is another 100 miles. Add those two together, you get 320 kilometers is 200 miles. And then the 160 and the 160, sorry, the 320 and the 160 makes 480 kilometers. There we go, would be 300 miles. So that's the first conversion. 480 kilometers is 300 miles. But she plans to drive on an average speed of 50 miles per hour. So if you think about how many 50 miles go into 300, then that should be the answer. So how many 50 miles go into 300 miles? Well, you're going to get 30 divided by 5, which is 6 lots. So it should take 6 hours at that average speed of 50 miles per hour. So if you kind of work back from the answer that you think it is, 6 hours at 50 miles per hour is 6 times 50 miles, which is 300 miles. And we've already worked out that 300 miles is the 480 kilometers, which is what we needed here. So that would be my answer, 6 hours. Right, so for this question, we're now completing the table of values for this quadratic function here, y equals x squared minus 2x minus 1. Now the nice thing about this is, if we look at this expression here, then when x has the value 0, then the value of this expression becomes negative 1, which is really the y-intercept. So when you come to doing graphs, you should have been taught a little bit about the intercept. It's basically the value on the y-axis when x is 0. So in this case, so I've got to get my scale right. So I'm going to say, okay, there's going to be my negative 1, and I'm going to plot that as we go along. So 0, negative 1 is there. 1, negative 2. So 1 along, 2 down is going to be there. 2 along, 1 down is here. Now, with these kind of questions, it really now depends how much you know about quadratics, because I know some of my brighter students that I've taught over the years would straight away go with x equals minus b over 2a, and they'd say x is minus b, which is minus minus 2, which is 2 over 2 times 1, which is 2. So they'd have x equals 1 is a line of symmetry. But if you don't know that, then that's really not a problem. Don't worry. So it's useful to know that. Another thing is, if you've got x squared minus 2x minus 1, you can just plug the numbers in, which is what this is really getting at, but it's not necessarily the best way of plotting a quadratic, but it's a way of doing it. So if you put 3 into here, you'd get 3 squared minus 2 times 3, which is 6 minus 1. So that's 9 minus 6 minus 1, which is 3 minus 1, which is 2. Okay, so you get 2 there. So let's rub that out. Now we want to put 4 into the expression. So we'll just plot 3 first. So 3 along, 2 up. The nice thing to know about the line of symmetry is that all the points are the same distance away from it. So you can use this situation to go 1, 2 along here should be 1, 2 along here. So you could almost guess here that when x is -1, we're going to have 2. So that would help us if we knew the line of symmetry. So we're going to put this 4 in next. So we'd have x squared minus 2x minus 1. And if you put 4 in here, we'd have 4 squared, 16 minus 8 minus 1, which is 8 minus 1, which is 7. So 4 along, 7 up here. I'm going to keep going on about this line of symmetry here because it's quite important to try and teach you a few things as we go. This distance from the line of symmetry, if I carry this on, this distance here is 1, 2, 3 units, and so it's got to be 3 units back here as well. So I think you can see that if I went back 2, I'd be up at 7, and that was one of them that was given for us, so we could definitely put that one in. So we now have to try and put in this value here, and that's going to be the one that's going to be most difficult for people. The reason being is because if you have x squared minus 2x minus 1 and you put -1 in there, a lot of people don't write that step out in the exam. They try and do it in their heads and they go wrong because -1 squared, in fact anything squared is never going to be negative. So you're going to have -1 squared is going to be 1, minus times the minus is plus 2 minus 1, so you're going to get 3 minus 1, which is 2. So that was correct. So -1, 2, there we go. So that's the thing to watch out for, is the negatives. You can get around that with the line of symmetry, but like I said, if you don't know the line of symmetry, then you're going to have to do some substitution. There are other ways of doing this by looking at the differences between the values and then looking at the second differences. They should be all the same. Whether your teachers explain that to you or not, I don't know. One thing to watch out for is some people think that when they join these up that they're just going to do straight lines here. No, because a parabola or a quadratic has a nice smooth graph to it. It's not going to be suddenly jagged. It's certainly not going to have a vertex there in terms of a straight edge, meeting a straight edge. So that's one thing to watch out for. The other thing is some people, they start off really good with the coordinates and then they go wrong. What they do is they have the first few and then they start the quadratic nicely and then go off somewhere. It's going to be quite predictable, the quadratic, so that's another thing to watch out for. So how would we draw these, join these up to get a nice smooth curve? Well, I would always turn your page upside down, and I would have your hand underneath the actual crosses, so it's like the arc of a rainbow. So you've got your hand here and you're drawing it so you're underneath the arc every time. If you do that, you'll get a smoother curve coming out. So when you're drawing cumulative frequency curves as well, that's a good idea. So you can take your hand off at this point here and then you can just turn your page a little. So I'll try and do that without messing it up. Turn your page a little bit here and then carry on through. I'm turning the page a little bit more and then carrying it on without making a mistake. Okay, so let's go back to where we were. That is how I would draw that graph from those values -2 to 4. So that's the first part of the question done. The next part of the question is, strangely enough, I had one of my students come to me the other day. She's a very bright student and she has trouble with these, so hopefully she'll be watching this video at some point. How would you solve that equation? So it says on the grid, draw the graph. We've done that. Now we've got to try and solve that equation. I think what you don't do in this situation is try and solve the equation. It does say that here, and you know, a lot of students do read things literally. I'm one of those people as well. I have the danger of doing that. So if you were to read this like this and solve it, you could take x from both sides and you'd have x squared minus 3x minus 1 is 3, and then take 3 from both sides, you'd have x squared minus 3x minus 4 is 0, and then you can try and factorize that, and you'd have x here, 4 and 1, both signs are unlike and the minus goes with the biggest, and you'd have x is -1 and x is 4. Now I did that purposefully quite quickly because although that would be the answer, I think what the question's actually looking for is, it said you've plotted this part here, and you want to see where that graph, this parabola, is equal to a straight line, i.e. where a straight line of gradient 1 intercept 3. So I suggest that you look at this anyway. Let's have a look. So if we want to plot y equals x plus 3, well, think y equals mx plus c. The intercept here would be at 3. And it means here the gradient is 1, so it means for every 1 I go along, don't forget this is 1 here, I need to go up by 1. So there would be my next point. So I'm just going to draw these points in green to show the differences here. So go along 1, up 1, go along 1, up 1 again, and then go along 1, up 1 here. Well, you can see they coincide. So x equals 4 was indeed one of the solutions. Also, it means if you went along back 1, you'd go down 1, and here's another one. You've got x equals -1. But I think the nice touch to do here would be to draw a straight line going through these points. So if I try and do that without messing it up, let's have a line here. And I'm just going to try and move that through these points here. That would be my line y equals x plus 3, and this would be my parabola y equals x squared minus 2x minus 1. So if I wanted to solve that equation, I could see where the line cuts the parabola. I've just had a look at the mark scheme. Now, one thing to note here, if I get rid of some of this stuff here, when I used to look at these questions, you know, years back, we used to say use the graph to solve. But the method I did first was actually okay. You could have actually done that. In fact, you could have done it both ways. You could have drawn the line through here and did it that way, or, and I'll take this through a slower way now, if you have x squared minus 2x minus 1 is x plus 3, it's giving you the choice to do it by using the graph or a purely algebraic method. So if you take x from both sides here, you'd have x squared minus 3x minus 1 is 3. And then you could take 3 from both sides here and have x squared minus 3x minus 4 is 0, and then factorize that. So when we come to factorizing this expression here, you really want it to be a situation where something multiplied by another thing gives you x squared minus 3x minus 4. So you'd want an x in either of these. And you want factors of 4, so 1 and 4, 2 and 2. So if you tried 2 with the 2, you'd have x squared, a 2x and a 2x and a 4. For starters, if you made this a plus and it's a minus to give you the minus 4, then you're going to have a plus 2x and a minus 2x, which will give you just x squared minus 4. So you'll miss out this term here. So what you'd probably have to do is just try the separate factors, which are, let's go 1 and 4. And then you'd have x squared, x, 4x and 4. So if you wanted to have a minus 4, when you've got two options, you can either have the minus here and the plus here. That would give you the minus here, the minus here. So you'd have minus x plus 4x, which would give you 3x. That would be incorrect. So your only other option would be to say, well, I'll make this the minus and this the plus. So you'd have a minus here, so you'd have your x squared and your minus 4, which is what you wanted. But here you'd have an x and then minus 4x, which would give you the desired result. So you've got x plus 1 here, x minus 4 here. So from this bracket you'd have x equals minus 1, because that's what would make it 0. And from this one you'd have x equals 4. So I don't know what you prefer really, whether you prefer to draw the line and do it graphically, or whether you prefer to do it purely algebraic. Maybe you're one of those students that would want to do it both ways. Okay, there's no harm in that either. You won't get any more marks, but you'll definitely get the 6 marks that you needed. Okay, what's the next question? So it's really asking for the interquartile range here. So if you think of inter as in between, so intercity is like a train that goes between cities. So you want between the quartiles. So you're kind of splitting your data up into 1 quarter, 2 quarters, 3 quarters, and 4 quarters, which make all of it. That's different to percentiles. Percentiles are splitting it into 100 parts, so you get the first 100th, the second 100th, all the way up to the 100th. So in this case, we're looking for between the quartiles. Now, it happens to be between the second and the third, but let's work it out from here. When you're looking at a box and whisker plot, this will be your lowest bit of data. This will be your highest bit of data. This part here is 50% of your data, okay, which is quite difficult for some people to get their head around. Basically, what it's saying is sometimes when you've got quite disparate data, which is quite different, instead of looking at the range, which you might have done in year 7 or year 6, i.e. the highest minus the lowest, that tells you the spread of all the data, because you're just comparing the highest number with the lowest number and seeing how different that is. Whereas when you look at box and whiskers, you're actually just getting rid of the highest and the lowest. You're not really taking that into account. You're looking at the kind of the middle-ish 50% of the data. Okay, so you're not looking at all of it, you're just looking at 50% of it and looking at that range. That's what the interquartile range is. So the things to know here is that on the diagram, this will be your lower quartile. So that's really like your first quarter. Your second quartile is your median, that's your halfway point. And your third quartile, which is your upper quartile, is here. Okay, so when you look at this diagram here, this is 50% of the data. This was like the 25% mark up to here. This was like the 50% mark, and this was the 75% mark. So we want to look between the upper and the lower. So the interquartile range is always the upper minus the lower. Now, I've drawn all over this diagram, so we'll try and make do with what we've got. I want to mark off what the upper quartile is. Well, this is 5.5, so that's got to be 5.6, 5.7, 5.8, 5.9, 6. So be very careful. The upper quartile here seems to be 5.6, and the lower quartile, well, that's 4.9, that's 4. Let's have a look. 4.6, 4.7, 4.8, 4.9, 5, well, this is trying to trick you here, which is not very nice. This will be 4.6, 4.7, 4.85, and that's my lower quartile. So I want the difference between those. So if you write it like this, well, you've got your subtraction, however you do that. I've got 0.75 kilometres. That's what I would have as my interquartile range. So what's the next thing to look at? Well, that's the interquartile range done. It says there were 80 players in Colin's sample. Work out the number of players who ran a distance of more than 5.6 kilometres. Well, this is the whole thing about what I was saying, because if you were getting to the 25% mark by about here, then this must be 25%. And if you were at the 75% here and at the end here, then this must be the 25%. So it says work out the number of players who ran a distance of more than 5.6. Well, if 5.6 was at the upper quartile mark, then really you've got 25% of the data would be 5.6 kilometres or more. So we've got 80 players here, and we've got to have those who ran a distance of more than 5.6 kilometres. So that would be 25% of them, which is a quarter, and a quarter of 80, that would be, I would write 20 players. So the next part, or the last part, it's saying, compare the distribution of the distances run in the first half with the distribution of the distances run in the second half. Well, you really want to be comparing these now. And what the examiner is going to be looking for is you to have some kind of commentary on how spread they are and compare the median or one of the averages. So in this case, you can quickly compare both. So if you look at the interquartile range for the first half, well, you've already found that. So you had the IQR was 0.75 kilometres. Well, what is it for the second half? Well, we've got 4.1, 4.2, 4.3, 4.35 versus 5.1, which is 0.75 again. So the second half, the interquartile range is 0.7 kilometres, 0.75 kilometres. I'm just going to check that just in case it isn't. So 4.35, 4.1, 4.2, 4.35, and then 5.1, so 0.65, 0.75. So you'd say they have the same spread, but if you look at the median for the first half, so if you look at the first half median, well, that would be 5.1, 5.2, 5.3, and for the second half, the median would be 4.5, 4.6, 4.7, 4.75. So you would say the first half had a higher median. So I think once you've got that information there, it's pretty easy to say that in the second half, and I'm not going to write all this out, you just want to say in the second half, on average, they ran less in terms of kilometres because the median was lower in the second half than in the first half. However, when comparing the spreads, 50% of the data, don't forget, is the spread. They were very comparable in terms of distance ran. So they're the two things that I would be putting in to that explanation. So let's have a look at the next question. Write down the value of 10 to the 0. Well, a to the 0 is 1, so 10 to the 0 is going to be 1. Now, one way of looking at that is if you had a to the 1 divided by a to the 1, then that, by the rules of indices, is a to the 1 minus 1, which is a to the 0. But you also know that a divided by a is 1. So that's one way of thinking a to the 0 is 1. Now, it doesn't have to be a to the 0. It could have been 10 to the 1 divided by 10 to the 1. Well, you know that's 10 to the 0 if you know the rules of indices. And 10 to the 0, well, what's 10 divided by 10? That's 1. So 10 to the 0 is 1. Another way of looking at it is if you had 3 to the power 2, that's 9. 3 to the power 1, that's 3. So 3 to the power 0, what would that be? Well, if you know what 3 cubed is, that's 27. These numbers are becoming 3 times less each time. And 3 times less than 3 is not 0, that's 3 less than 3. 3 times less than 3 is 1. So 3 to the minus 1 will be a third, and 3 to the minus 2 will be a ninth, and so on. So that's the answer to the first part. Write down the value of 10 to the minus 2. Well, 10 squared is 100. 10 to the 1 is 10. 10 to the 0 is 1, don't forget. 10 to the minus 1 is a tenth. So 10 to the minus 2 would be 100th. Write these numbers in order of size. Start with the smallest number. So we want S here, L for largest. So let's go through these. Let's start with this one. So that's 2.73 times 10 times 10 times 10. So I'm really timesing it by 10 3 times. So I'd have 2.73 times the 10 is 27.3. Times the 10 again would be 273. And then times the 10 again at the end would be 2,730. So that's 2,730. Let's look at this one next. That's 273 times 10 and by 10 again. So that will be 2,730, and then times 10 again will be 27,300. This one, luckily enough, is given for us already. And 27.3 times 10 to the minus 3. Well, this minus 3 here, just like we had, say, down here, would be repeated division. So we want to divide by 10 3 times. So if you have a number x and you want to times it by 10 5 times, you'd write 10 to the 5. Whereas if you wanted to divide by 10 5 times, you'd do 10 to the minus 5. So we take 27.3, we've got to divide it by 10 3 times. So divide it by 10 once, we'd have 2.73. Divide it by 10 again, we'd have 0.273. And if we divide it by 10 again, we'd have 0.0273. So, write these numbers in order of size, start with the smallest. So the smallest number here is going to be this one, because it's in the tenths, the hundredths, the thousandths, so it's got 2 thousandths, and it has no hundredths or no tenths, so this will be the smallest. So that's done. The next smallest will be this one, so we'd write 27.3 times 10 to the minus 3. The next smallest, 2,730, which is 2.73 times 10 to the 3, and that would then be the largest, which is 273 times 10 squared, or 10 to the 2. So that's how I'd write my answer. But like I said, you're going to have to know standard form versus ordinary numbers. This is standard form, this is an ordinary number. So let's look at the next question. Solve the simultaneous equations 4x plus y is 25 and x minus 3y is 16. Well, this is where two straight lines cross in space. So if you don't know about that, then you're going to have to look at simultaneous equations and understand what they actually mean. Again, I can put links on here to certain videos that I've got where I explain how to do them and what they mean. Let's have a look at this one. So if we've got 4x, let's change the ink colour here. Let's say we've got 4x plus y is 25 and x minus 3y is 16. Call those equations A and B. The way I usually do this is to try and get the coefficients of x or y the same. So in this case, I'm going to try and get the x coefficients the same. So I'm going to times equation B by 4, and that would give me 4x minus 12y equals 64. Call that equation C. Now you don't have to label these A, B and C, but I'm just doing this so my working out is clear so you can understand. So what I had was, if I did that, I'd have 4x plus y is 25 from equation A, and I'd have 4x minus 12y is 64 from equation C. The nice thing about simultaneous equations is that if you treat them like a pair of scales, that means if I added both of these sides together here, it would balance with the sum of these two sides. But if I added them, I'd get 8x minus 11y is 89, and that's not going to isolate x or y for me. So what I'm going to do here is, which is what I normally do, I write out the equation again, just so you can actually see what's going on. So I get to this situation, and in other videos that I've got, there's plenty of questions where I've demonstrated how. And the way I've taught my class is this for years now. I would times one of the equations through by negative 1. So we'll times by negative 1, by negative 1, by negative 1. So I've done everything through by negative 1, and then I always add. So if I add them together, I'm going to get no x's. I'm going to get 13y, and then 25 minus 64. Well, that's going to be minus 39. So y is going to be 13 times less, which is minus 3. If you didn't like that, so what I'm trying to do with this video is not just to do the question necessarily, but try and explain a little bit as I'm going along in a bit more detail. You could have times this top one by negative 1 and then added. So you would still get 0 here, and you'd get minus 13y is minus 25, add 64, which is 39, and divide both sides by negative 1, and then divide by 13. So you get y is minus 3, just the same. Now once you've got y is minus 3, you've got plenty of choices now. You can either substitute y is minus 3 into one of the equations, and I'll do that first. So this is the substitution method. So if y is negative 3, if I put this in equation A, I'd have 4x plus minus 3 is 25. So that gives me 4x minus 3 is 25. Add 3 to both sides. So that means 4x is 28, and divide both sides by 4. So x is 7. So y is minus 3 and x is 7. And that would be the coordinate of where the two lines crossed in space. That was just a guess at what they look like. They may look different, but I'm not going to get into that right now. So x is 7 and y is negative 3. But the other way you could have done it was just by starting the whole process all over again. And I'm not going to label these this time, but you can just times the top one by 3. So you'd have 12x plus 3y is 75, and then add the equations again, and then you'd have 13x equals 91, and luckily 7 13s are 91. Harder, but if you left the answer as x is 91 over 13, you are not going to lose marks. So 91/13 would be absolutely fine. So don't worry too much as long as you leave your answer as a fraction. Don't try and doing long division because I see a lot of students doing that and wasting an awful lot of time. Just leave it as a fraction and that will be absolutely good for the marks. Okay, so what's the next question? It says the diagram shows a straight line L1 drawn on a grid, and it says a straight line L2 is parallel to the straight line L1 and passes through the point 0, -5. Find an equation of the straight line L2. Well, these are by far the most difficult questions that I've found over the last 20 years of teaching. That and percentages get students every time. So we're going to take it slow on this question and see what we come up with. Well, let's underline some of the key words. So L2 is parallel to the straight line. A lot of students make the mistake and do perpendicular. It's not saying at right angles to it, it's saying parallel, and it passes through the point 0 and -5. So let's try and work out what we can about the first line and then try and work out what the second line is. So the first line, L1, is such that, well, it's going to have the form y equals mx plus c, and we also know that here the intercept, the y-intercept of L1 is 3 units, so we know it's y equals mx plus 3 at least. But can we work out its gradient? Now the gradient is really the times table that it's going up in terms of a sequence if we were to plot the y coordinates. So I'll give you an idea. Let's have a look at the gradient of the first line. So if we went along 2 units here on the x, we're only going up 1 here. If we went along 4 units here, we're going along 2 here, okay, because this is 3 here. So if we went along, and I'll just expand this out a little bit, if you can work out how much you go up if you go along 1 unit, so there's 1 unit there, how much do you go up? Well, if you went along 2 and up 1, then by similar triangles, going along 1, you'd actually be going up by half. Okay, that is a half. So the gradient of the first line is a half. Now, some of you who are at the top end of GCSE would know delta y over delta x, or some of you may have even heard of dy dx. So if you do the y over the x, you'll get the gradient. So you could just gone 1 divided by 2 or 2 divided by 4. They all give a half. Okay, so if you do the y divided by the x, that will always give you the gradient. So we can definitely fill that in now. That's one little missing piece. And of course, you'll do this a lot faster in the exam than what I'm doing here. So you've got a half x plus 3. So that's good because we know that the line L2 has to be parallel to this line. So it's got to have the same gradient. Okay, so it's got to be parallel somewhere. It's got to have the same gradient. So we know that L2, we've got part of the missing link, and we're going to get some of these marks already. So y is going to be a half x plus something. Okay, but we know that it passes through the point 0 -5. So if it passes through the point 0 -5, doesn't that mean that its intercept is going to be -5? So we can just say here, L2 is such that y equals a half x minus 5, and that would be our answer. So try and think of the actual terms we've got here, parallel, and look for information that we can easily take from, i.e. can we see where it cuts the y-axis? And if we do, and if your teacher's taught you reasonably well enough, then you should be able to pick up quite quickly what the intercept is. This is the intercept, this is the gradient, and go from there. Right, in this question, we've got a photo, rectangular piece of card, and it says here the photo is 16 by 10 and the card is 30 by 15. Steve cuts the card along the dotted line shown in the diagram below. and basically throws away a piece of card that is 15 by x, and the piece of card he has left is mathematically, right, here's the killer word here, similar. So we're going to be talking about similarity here, and if we can use mathematical similarity, then we should be able to work out the value of x that we need. Well, I find these questions quite difficult. I don't know about whether you do, but he basically throws away a piece of card that is 15 by x. So he's kind of wanting, I think, the frame to look nice and just cut this bit off. Okay, so that's that part here. So I think if I was looking at this question here, I know I've cut off some of the card. I want to make the frame in proportion. That's the important word here, proportion and similarity. So you kind of want to see how this part here corresponds to this part here, because they're in proportion with each other. And when you cut off this bit here, if you're not careful and this part is not in the same proportion of what you've got left, it's going to look off-centered. It's going to look a bit dodgy, to be honest. So I know in real life you just cut the scissors where it looks right, but for this question it's about accuracy. So we're going to look about how we've got the photo to the card, and we know in the photo we've got 10 centimeters and in the card we've got 15. I'll write that a bit better. We've got 15. So 10 to 15, divide both sides by 5, we've got 2 to 3. So that's quite important there. So we've got a ratio of 2 to 3, or we can look at it as a scale factor. We can say, well, 10 times what is 15? So we can say 10y is 15, for example, where y is the scale factor of enlargement. So that means y will be 15 over 10, which will be 3 over 2. Okay, now we could have got that from here. If we'd have said the photo to the card is 2 to 3, we could have had a unitary ratio here. And we could have said for every unit on the photo, the card is 1.5 times bigger, or 3 halves bigger. So I'll just go over that once more. So you can do it this kind of way and get the photo as 1 unit, and then you know that 1 unit here corresponds to 1.5 units there. So i.e. the card, every 1 unit on the card, this is 3 halves bigger, or 1.5 times bigger. Or you can say 10 times something is 15 and work out what that something is, and that will be the scale factor of enlargement. I don't tend to use decimals very much, but I'll put it in there in case some of you are thinking it's 1.5, which it is. That's absolutely fine. So you want to try and now work out what the relationship would have to be for this side now. So this is 16. What would this have to be? Well, 16 would have to be times by the same scale factor of enlargement. And instead of doing 16 times 3, I would do 16 divided by 2, which is 8, times the 3 is 24 centimetres. So really, what you're working out is, you know that this now has to be 24. Okay, so that we've worked out. So this was good, and we've got 24 left there. So we've now got to work out the value of x. So what would you do next? Well, hopefully you wouldn't worry too much, and you'd say, well, surely it's just got to be 6, because if this was 6 added to the 24, you get back to the 30, and that would be exactly the right answer. So let's just write it in here. X would be 6 centimetres. Okay, so I hope that one was explained well enough. When you think similarity, you've got to think proportion. Things have got to be in the same proportion. When you've got similar triangles here, it means that if you want to times all the lengths by a scale factor of 2, you're still going to end up with a triangle. If you don't times all the lengths by the same thing, you'll end up with something that will look pretty strange. Okay, so mathematically similar in terms of objects is quite an important concept in maths. So let's have a look at the next question. Circle theorems, one of my favourite topics. let's have a look, because I know it's not everyone's favourite over the years, and I think that depends on how you've been taught. And I think it's quite hard for a lot of teachers to teach this. I'm not pretending I'm the best teacher in the world, trust me, but circle theorems is something that I've struggled with as a teacher for many years, and it's something now which I feel like I can do reasonably well, but it's taken a long time. So how it feels for you doing the exam must be even harder. So let's have a look at this circle theorem and let's see if we can answer the question. Now it says B, C and D are points on the circumference, and it has a centre here, and it says ABE. So that's the first thing. If you're not quite sure how to mark these angles, then ABE would be A to B to E, and ADF are straight lines, so they're tangents to the circle, so they must be, angles have got to be 180 degrees. So don't get confused with what ABE means. You can look at it as an angle, or you can just look at it as going from A to B to E, okay, in a straight line. So that's the first thing to look at. And then it says angle DAB is 40 and angle CBE is 75. You've got to work out the angle of ODC. So you've got to work out this angle right here. So how are we going to do that? Well, there's a few things that you've got to work out with circle theorems, and let's go over a couple of things here that are evident in this diagram. The first clue is, it says that ABE and ADF are tangents to the circle. So when I teach this, I always say to my students, look for where the radii are. So the first circle theorem is that the angle between a radius and a tangent is 90 degrees. So this is 90 degrees here, and this will be 90 degrees here. Now if you look at this shape here, then you've got now a four-sided shape, a quadrilateral, and you know that angles in a quadrilateral add up to 360. So you'll be able to say that angles in A, D, O, B equal 360 degrees, and you've got 90, 90 more, and 40, so you've got 220 degrees already. So how much is left? Well, this centre angle then must be 140 degrees. So you've got to say to yourself, you've got to get these marks, so you say angle DOB, not the reflex one, but the obtuse one, would be 140 degrees. Okay, now usually it asks you to give the reasons. It doesn't ask you for the reason here, but I would. So the first thing I would say is here, angles between a radius and tangent are 90 degrees. Okay, so you can mark those in the diagram, and then you can do this bit of working up here to get to DOB. Now it wants you to think about how to work out the size of ODC. So don't forget that was this angle here. So how would you go about doing that one? Well, have a think about the diagram and then see what you'd come up with. So looking at the diagram here, we've worked out that the centre angle is 140. So another circle theorem kicks in, and that is the angle at the centre is, what do you think it is? Twice angle at circumference. Now I've used L for angle there, and I've used angle as in words there, so as long as you understand they're the same thing. So what it's saying is that if this angle here is 140, then this angle here has to be 70 degrees. So we've worked out that. We now also know that this is 15 degrees, surely, because we know that this was a right angle also, because it's the angle between a radius and a tangent, don't forget. So we've got another situation going on here where we've got a quadrilateral that looks like this. And we know this angle, we know this angle. We can definitely work this one out because it's 220, don't forget. Because angles round a whole turn is 360. So we've just got to work out that one. So if we work out all the angles we do know, we've got 220 and the 85 for these two is 305. Well, that leaves 55 for the angle that we wanted. And now it's kind of coming to mind that it's probably why they're not asking you to give your reasons for every single step, or you'll be just taking forever doing it. But we've got to the situation where angle ODC is 55 degrees, and we've probably shown quite a lot of working there. Okay, so that's that question done. I think in most questions you'll probably be asked for one or two reasons, but in this case you just had to work your way around the circle. I guess the thing to not fall for was there's no symmetry here, so you could have thought that there was symmetry here because they look similar, but no, they're not. And I don't mean the word similar as in similar triangles, they just look the same, but they're not. So don't assume symmetry, it's a really dangerous thing to do. You must work your way around the shape and write down all your steps. So that's that one done. So let's have a look at these now. So a lot of common mistakes happen here. When you've got a question like 3x squared y to the 4 all to the power 3, it's tempting just to times the powers out and write something like this. And unfortunately, you wouldn't be doing too well if that was your answer. What you should do is look at what's inside the bracket and cube it. Okay, you don't have to write this out 3 times, but I'm just showing you what's going on in my mind here. And then you would see that you'd have y to the 4 times y to the 4 times y to the 4. It's all timesing. Everything is timesed here. So you'd get y to the 12 in your answer for sure. And then you'd have x squared times x squared is x to the 4 times another x squared is x to the 6. Doesn't matter which order you write these in. And then you've got 3 times 3 times 3. And that's where you went wrong here. That's how you would have done it. So you've got 3 times 3 times 3, which is 27. So the answer would be 27 y to the 12 x to the 6, or 27 x to the 6 y to the 12. But please don't be writing x to the 6 27 y to 12. The number always has to go in front. For example, if you think of 4a, don't be saying A4, because A4 is with a piece of paper. In fact, it's with a capital A. So numbers first, then letters. That's just the way mathematicians want stuff done. So that's that one done. With this one now, these are really nice if you like your algebra. If you don't, and you're a foundation student that's trying a higher paper, then these are going to be where there's a lot of marks, but you may not be able to break through to them because you may not have had enough experience of algebra in your previous years at school. So I'll break this one down reasonably slowly. So the first one here, well, I think difference of two squares because I have x squared, which is x times x, and I have 9, which is 3 times 3. And for some of you, you may already know the difference of two squares formula. That's a squared minus b squared is always a plus b, a minus b, and that comes from this situation here. So you'd have a squared, you'd have ab, you'd have minus ab, and then minus b squared. So you get your a squared minus b squared, and these always cancel. So if we write out the top here as x plus 3, x minus 3, which we can, and you can just test that in a grid, and you'll see that it's always going to be x squared minus 9. Then the key here, if you don't have experience at algebra, then the key here is if you're asking to simplify, then you're asking for hopefully there to be an x plus 3 or an x minus 3 underneath. So if you don't get either of those, you've probably done it wrong because it's not going to simplify anymore. So let's have a look. How can we get 2x squared plus 5x minus 3? Well, let's just say that we try to find an x plus 3 again. So we'll definitely keep x plus 3 in here. Then that's got to be 2x. So we've got, put that plus in there so you can see it. That's going to be 2x squared, and this is going to be 6x. But I don't have 6x, I have 5x, so I've really got to go back by one value of x here to get to 5x. So that will give me my minus x, and then this will be minus 3. So would that work? Did I strike lucky straight away? Well, 2x squared, yes. 6x minus x is 5x minus 3. That's good. So I was actually lucky. If, for example, you chose x minus 3 here, you would have been one of the unlucky ones because you would have had to have done 2x here because only 2x times x is 2x squared. Then you'd have minus 6x here, and then you'd have had to have a minus times, well, a what gives a minus? A plus, and this would have to have been plus 1, and then you'd have had an x and then minus 3. So although these would have been correct, that would have been minus 5x because x and minus 6x is minus 5x. So what would our final answer be? Well, these cancel nicely because x plus 3 divided by x plus 3 is 1, and my final answer would be x minus 3 over 2x minus 1. Don't go messing it up at the end and try and do this because that's, I'm afraid, really breaking the rules of algebra. Just leave it as that. Okay? So, a bit of probability here. 10 tulip bulbs in a bag. 7 of them are red. So, I'll just I'll do them in the same colour, but I'll put R for red. So we'll have 7 red and 3 of the yellow. Okay, and they're in this situation. And Yvonne takes at random 2 tulip bulbs from the bag. She plants the bulbs. Well, it's saying here that the chance of getting a red is 7 out of 10 because there are 7 reds and there's 10 altogether. So how many for yellow? Well, that's going to be the remaining 3 out of 10. Now, this is the difficult part because it says Yvonne takes at random 2 tulip bulbs from the bag. So she's got to take 2 out. So if you take the first one out, you're not putting it back in again. So if you were to take a red out of the bag, how many red ones would you have left? Well, and you wanted to pick another red one, well, you'd only have 6 to choose from, but you wouldn't have 10 bulbs in the bag anymore. You'd only have 9 left. Okay? Look at this situation here. What would you have? Well, you took a red out, so you want to now have a yellow. Well, you didn't take a yellow out, so there's still going to be 3 left in there. And how many bulbs are going to be left in? Well, you took a red out, so you're going to be left with 9 still. Okay? Notice how these 2 add up to 1 and these 2 add up to 1. They must always add up to 1, okay? So 6 ninths and 3 ninths is 9 ninths. So let's look at yellow. So you take a yellow out and you take another yellow out. Well, it's going to be 2 yellows left out of 9. And so the reds, well, that must be the 7 that we had before because they were not touched the first time round. And that's our probability tree diagram sorted. Now it's probably going to ask us something else now. And it says, work out the probability that at least one of the bulbs will grow into a yellow tulip. So at least one of them yellow. And I always teach my students to do where it's not yellow at all, i.e. both red. So the probabilities here, we're going to have 7/10 times 6 ninths. And that's going to be, well, you can either cancel these out. I don't. I think it's a really bad idea because you'll have 42 out of 90. And this 90 tells me there's 90 choices going on. and only 42 of those choices were the ones I wanted. If you start cancelling down, you're going to miss out what the question is really talking about. It's all well and good to cancel, but I'm afraid generally in probability it's not good to do that here, not at this part anyway. So when you get to 42 over 90, just leave it as that, because now you see that all the other chances are going to include yellow at least. So you know if there was 90 chances where you could pick the different bulbs, then if 42 of those chances out of those 90 were involving red, then all the others have to have yellow at least, i.e. yellow and a yellow, or yellow and red, or yellow and yellow. So you've got 48 chances left. So I would say 48 out of 90 would be my final answer. I wouldn't cancel that down, although I know a lot of students that probably would. So that would be my answer. Well, we've got quality of written communication again, this time with a vectors question, which again makes most of the students that I've taught over the years feel with dread. So I'll go over this one reasonably slowly. It says OAB is a triangle, M is the midpoint of OA, N is the midpoint of OB, OM, the vector O to M is M, and O to N is N. Now, you can't generally write in bold in the exam, so if you were to write a vector like M, you'd have to put a squiggle underneath to show that it's a vector, and likewise like so. You want to show that AB is parallel to MN. Well, first of all, how would you define the vector A to B? So you want to go from A to B. Well, the way of doing it would be, you could say this. So the journey you could take, always look at journeys. You could go from here to here and then from there to there. So if you went from here to here, how far would you be going? And then you have to go plus this journey here. So before you can do that, you know that O to M is M. So this must be M as well. Why? Because M was the midpoint. Likewise, if you're going from O to N here, which is N, then N to B must also be N. So that's one of the first things to look at. So that's using the rules about the midpoints. So I'll just go over that once more. We know that this vector from here to here is M, but because M was the midpoint, then we'd have to move the same rule again, the same gradient, so we'd have M again. Okay, so O to A, let's just write that down, is going to be 2M. Likewise, O to B is going to be 2N. So now let's do our journey. How do we get from A to B? Well, we go back here, because don't forget this vector is going this way. So if that was 2M going in this direction, then if we go in the other direction, it'll be minus 2M. So we know A to B is going to be A to O plus O to B. Now A to O is going the opposite direction of this one, so it'll be minus 2M, plus O to B is just going to be in the same direction, so it's going to be just simply 2N. Now you can leave your answer like that. I would tend to do this and then take out a scalar. I don't know if you know what a scalar is. A scalar has no value. A vector has direction, a scalar doesn't. So we've got two lots of n minus m. So this part here is the scalar quantity, and this is the vector quantity, which happens to be your gradient. So the gradient of this vector here is n minus m. That's all you need to know. Okay, so that's A to B. And we want to show that's parallel to m to n. So if we write in here, let's do another colour. What would that be? Well, look at this journey again. If I want to go from here to here, it's the same as going along here first. So we write this out. We'll say m to n is going to be going here. So that's m to o plus o to n. So m to o is going to be in the opposite direction here. So it's going to be minus m, and o to n is plus n. So we have mn is going to be n minus m. And it says show their parallel. Well, for straight lines to be parallel, their vectors have to be the same. So if you want to write this in the exam, it's up to you. So you can see the scalars here are 2 and 1, but the vector quantity here, the movement part, is exactly the same. Therefore, mn is parallel to AB. Well, let's have a look at rationalising the denominator. Here we've got 12 over root 3, and we want to rationalise it, so we don't want to have an irrational number here. So the best way is to times it by 1, and that's made up of root 3 over root 3, because that's the same as 1, and that has the nice effect of doing root 3 times root 3. Don't forget, root 3 times root 3 is the same as 3 to the half times 3 to the half, which is 3 to the half add a half, which is 3 to the 1, which is just 3. Long-winded, but at least you understand why that's the case. So on top you'd have 12 root 3, and on the bottom you would just have 3, like we said before. And then 12 divided by 3, well, that would give you 4 root 3. What about this second one here? Well, I strongly recommend that you do a grid and would have root 2 and root 8, root 2 and root 8, multiply them out, so you'd have root 2 times root 2. If you don't like this idea of root 2 times root 2, then just think of it as this. Think of it as 2 to the half times 2 to the half, which is 2 to the 1, which is just 2. If you don't like that, you can think of it as root 2 times root 2, which is root 4. Okay, you can look at it in two different ways, but either way you're going to get to 2 as the answer. Root 2 times root 8, think of that as root 16. If you don't like thinking of it as this, you can do root 2 times root 8, but then you'd have to split this root 8 down into something else. You'd have to use the idea of surds. So you'd have to say root 2 here times root 8, which is root 2 times root 4. So can you see that root 2 times root 4 is going to be root 8? Now, if you look at root 4, that's just 2, but root 2 times 2 is 2. So you actually end up with 2 times 2, which is 4. Now, if you just do root 2 times root 8 and write root 16, either your brain will tell you, that's 4, or it won't. So let's just say it doesn't for now, and you leave it as that. Then you'd have root 16 here as well, and then root 8 times root 8 is root 64. But when you're looking at surds, always think of square numbers, so 1, 4, 9, 16, 25, 36, and so on. Try and look for square numbers where possible. So here we've got 2 plus 4, because that's the square root of 16, another 4, so that's 8, and then we've got root 64, which is another 8. So we've got 16 and 2, so the answer is actually 18. So we must be close to the end now. So let's have a look. Is this the last question? Yes, it is. And another tricky one here. It says, the diagram shows part of the sketch of the curve y equals sine x. Write down the coordinates of P. Well, if you know enough about the unit circle, then you'll know that if you have an angle here, this is the sine, this is the cosine. So we want to look at the sine graph and we want to see where it's 0. okay, because if we know where it's 0, we'll know where the coordinate P is. So if you have an angle of 90 degrees here, then if it's the unit circle, don't forget the unit circle has radius 1, then you'll know the sine of 90 is 1. Okay, so that's going to be this point here. This is going to be the highest point. This is going to be the lowest point, by the way, because when you're in the unit circle, wherever you are in it, so I'll draw different types of triangle here, your sines and cosines are always going to be restricted. They can't jump outside of this unit, so they can either be up to -1 here as sines and cosines, or they can be as high as 1 as sines and cosines, but they can't go over those two limits. So the highest that we can get for a sine is going to be here 1, so we know that would be 1 here. But where would the angle be 0 again? Well, at 0 there's no sine at all, and if we keep growing here, the sine will grow and grow to the point where it gets to 1, and then it will diminish more and more. We'd have to get to 180 degrees here for the sine to be 0 again. So this would be 180 degrees here. So this coordinate of P would be 180 degrees along and no height whatsoever. Now, I suggest that you do check out my video on the unit circle here, because I think that will help you a great deal. Write down the coordinates of the point Q. Well, again, if you've got a unit circle, this will be sine at its lowest value, so it would actually be when you turn all the way round to here. So I'll just turn this another colour. So if you turned all the way to here, this is where the sine would be -1, and that would be at 270 degrees. So this would be 270 degrees along here. So the coordinates of Q would be 270 degrees along and down 1. And this one's really important because it's really telling you that the circle has a radius 1. Now here's the last part now. It says, here is the sketch of the curve y equals a cos bx plus c. And it says find the values of a, b and c. Well, if we look closely at what we've got, I think one way of looking at this question to start with would be to say, well, it has the shape generally of a cosine graph. Okay, because if we were to carry this on here, it would be nice and symmetric, and cosine graph is nice and symmetric around the y-axis, whereas the sine graph is asymmetric. It goes like this. So we definitely do know it's to do with cos, and it says that here, so we're on to something there. Now, if we just try and draw the graph of cos x in there, y equals cos x, well, think of the unit circle. If we've got no angle, then the cosine is 1. So this would be 0 and 1 here. And if we had 90 degrees, then there is no cosine at all here, no cosine. So it would go through here. If we had 180 degrees, the cosine would be -1, which would be here. And if we had 270 degrees, again there'd be no cosine. And then 360 degrees all the way back would be back to 1 again. So if I plot that in there at least, then you'll see part of what I'm getting at. So we'd have a situation, let's just go here, so we'd have something like that. Now, that's not a brilliant graph, but it will do for now. So that would be the cosine graph. Now, what you can see is here that this point is in common with that point. What you can also see is that the difference between the highest and the lowest points here is the distance between here, which is 2. But on the graph that we've got that we want to look at, we've got a difference here of 1, 2, 3, 4. So there's a stretch factor in the y, in the y orientation. So we're definitely stretching by a factor of 2 in the y. So you should be able to work that that's the value of a, because if I have a f of x, then if I want to stretch in the y direction, then that's my value of a. So if a was a half, this graph here would actually squash in a little bit in terms of the y-axis. But here it's 2, because I've worked out that here it was started to be 2, but for the one I wanted, here it was 1, 2, 3, 4, twice as much. So I know the scale factor a is 2, but now I've got to work out b and c. So they are going to be quite challenging, but here's how you do it. I would start to look at the differences between the peaks here. So I'd say there's 1, 2, 3 gaps between the peaks on the one that I want, and on the one that I've drawn, cos x, I've only got 1 gap here. So if I compare those gaps, that tells me how to get from one peak to the other. That's all about the period of the graph, which I'm not going to go into right now because it will just make it more difficult. You just want a quick way of doing it. So for the cos graph, we had 1 gap, but for the one we wanted, we had 3 gaps between the peaks. So that was basically telling us that if we wanted to go from the green graph to the one we want, we'd have to squash it inwards by a scale factor of 1/3 to get to where we want. So squashing in by a scale factor of 1/3, you may remember, is all to do with this. Now if you had f of 3x, that would be squashing it in by 1/3 because you have to take the reciprocal of this number. That can be explained on another video, and I'm sure there's plenty of videos with good explanations on there. I'll probably do one myself now, because this is by far the most difficult question on this paper to explain. So we know that the value of b is 3, and I guess you should just try some of these out before you feel that you're really, got this topic nailed, because these are really difficult. You need to practice quite a few of these so you really get it in your head. So we've got b is 3, because that will squash it inwards by a factor of 1/3. And then we just have to find our c. So we've got a is 2, b is 3. We now just have to find the value of c. So how do you think you would do that? Well, I think one thing I would do is I would say where c is here, this point, if I try and make my value of x 0, I will get to this point here. So I'm just going to put 0 in here. So I'm going to have y is 2 lots of cos of 3 lots of 0 plus c, which will be y is 2 cos of 3 zeros are 0 plus c, and that gives me y. Now 2 cos 0, what's the cos of 0? Well, the cosine of 0 from the unit circle, if there's no angle, the cosine is 1. So I've got 2 times 1, which is 2 plus c. But where am I here? This is the intercept, it's 3, so this value here has to be 1. That's the only way I'm going to get to 3 here. So that's how I personally would do this question. And I think personally, I may do this question again as an appendix to this video, because it's quite hard to explain. It's quite easy to do, trust me, with practice, but it's very hard to explain without going into a lot of detail. So I hope that paper's been explained reasonably well. Do write some comments, do try and subscribe to the channel if you can. It does take a very long time to get these explained really well, but I'll try and do as many as I possibly can. Okay, thanks a lot then.